Hey everyone, as you know, there's no live lecture on Wednesday or Friday because I'm at a conference, and so instead for these lectures you're going to be watching podcasts. The reason I'm recording another video now is because the podcast that I intended to post for Friday's lecture, which is this one, has this like muffled or gargled audio at the very start, just for a few minutes, and so instead of forcing you to listen to that weird audio, I thought I would just re-record the first few minutes of the lecture. Okay, so recall, at the end of Wednesday's lecture, you were introduced to a new setting that involved ethnic distributions of jury panelists in Alameda County. Specifically, you looked at two distributions. One distribution we looked at involved the ethnic distribution of everyone who is eligible to be a jury panelist in Alameda County. And so since this distribution represents everyone, we're treating this as our population distribution. The other distribution we had access to was the ethnic distribution of the 1,453 people who were actually on jury panels. So the first distribution is everyone who is eligible to be on a jury panel, and the second distribution is everyone who is actually on a jury panel. And so that first distribution, which represents the population of Alameda County, is in the eligible column here. And that second distribution, our observed sample, is in the panels column here. And we can see that they look quite different, right? In the eligible population, 15% of individuals are Asian, and 18% are Black, and 12% are Latino, and so on and so forth. Though in our actually observed jury panel, it seems that 26% were Asian, and 8% were Black, and 8% were Latino, and so on and so forth. And so the question we're trying to answer is, does this sample of actual jury panelists look like it could have been a random sample from everyone who is eligible to be on a jury panel? Does this column look like it could have been drawn as a random sample from a population with this distribution? And so in order to answer that question, what we need is a way to describe numerically how different two categorical distributions are. To be clear, each of these columns individually is a categorical distribution. These five numbers, these five, they are a categorical distribution because they describe the frequencies of these five categories. Okay? So the eligible column, that's one categorical distribution, and the panels column, that's another categorical distribution. And what we want to do is somehow describe, using a number, how different these two categorical distributions are. And none of our previous test statistics are really well equipped to do that. Our previous test statistics included things like the number of heads in 200 flips of a fair coin, or the absolute difference in proportions of the expected number of purple flowers through a model and the actually observed proportion of purple flowers. Something like that, right? Though none of those accounted for the case where we have multiple categories, and so we need something a bit more sophisticated that can combine or describe how different this column is from this one using a single number. And that's where the total variation distance comes in. It's a way to describe how different two categorical distributions are. And the way you do it is by first taking the categorical distributions, so this column and this column, taking their difference, so 0.15 minus 0.26, 0.18 minus 0.08, so on and so forth. That'll give you five differences. Then what you do is you take the absolute values of all of those differences so that they're all non-negative. You take the sum of those absolute differences, and then you divide it all by 2. And the result is guaranteed to be somewhere between 0 and 1, where 0 means they're exactly the same distribution, so they're not different at all, and 1 means they're as different as possible. So the TVD, it describes from 0 to 1 how different your two categorical distributions are. Okay, that's all I needed to add here. I'm going to pass it back to Fall 22 me to continue talking about total variation distance and eventually permutation testing. Enjoy.